everyone, and thank you for participating today. The AIA Monterey Bay Committee on the Environment is pleased to bring you our first talk in our 2021 series on green specifications. This talk is focused on Division 1, Construction Waste Management. This webinar qualifies for 1.5 learning units and will be reported by our AIA MB staff. This lecture, after it's recorded, will be placed on the website under the COAT tab. At 1 p.m., we will open the floor to questions. You may enter a question in the Q&A box or raise your hand to ask a question live. We encourage you to speak and ask questions to our speakers. Here's our learning objectives for today. Throughout the webinar, I'm going to share some polls just to make this a little more interactive. So this is the first time we've done it, so kind of bear with me if there's any kind of pauses in that. I'm going to try to do the first poll here. Charmaine, are you able to post the poll?
Yes. You want the CN Tower, Toronto?
It's question number 1, please. Okay. So if people can, what is the largest man-made structure on the eastern seaboard by volume? All right, give it a few seconds. Okay, go ahead. Can you display the answers?
So I guess this is new. I guess I end the poll then.
Yeah.
Okay, and share results.
All right. And so fresh kills is what the majority guessed. And you are correct. Fresh kills landfill. So as many of you guessed it, yes, Fresh Kills Landfill on Staten Island is the largest man-made structure on the eastern seaboard by volume. In 2001, the landfill was 25 meters taller than the Statue of Liberty, and it was estimated that if kept open, the landfill would have eventually become the highest point on the East Coast. The city and many group of designers had a creative solution. However, it's now being transformed into a 2,200 acre public park, mostly grasslands. It will be the largest park created in New York City since the 19th century. However, most landfills don't have this type of happy ending. Construction and demolition, or C&D, is one of the messiest industries on the planet, especially when it comes to the waste left behind. According to the EPA, over 540 million tons of debris was created by American C&D companies in 2015, the same weight as over 100 Great Pyramids of Giza. According to Cal Recycle, construction and demolition materials are estimated to account for between 21.7 to 25.5% of the disposed waste stream. So how can we as architects and contractors help reduce C&D waste above what is expected of us? Waste should be at the front of our minds as we're beginning to conceptualize a project. It is a fact that 90% of a building's environmental impacts are determined by design. Therefore, as architects, we have a huge responsibility in designing buildings and sites that aggressively address our environmental issues. Most building materials are made from virgin resources, and when a building is refurbished or demolished, they end up being downcycled, incinerated, or landfilled. The negative impacts of this linear take-mix-waste resource flow are vast, and the construction industry is starting to experience resource scarcity. We've seen this especially in the past year, where COVID-19 has disrupted extraction and production of materials, and whose shortage has created a huge inflation in construction material costs. In contrast, a circular economy aims to design waste and pollution out of the system, keeping products and materials in use for as long as possible to regenerate natural systems. And we'll talk about this a little bit further into the presentation. So as architects, we have many options to reduce waste from the onset. I'm going to go through a number of examples. Here is an example of a panelized modular system, or SIPs, which stands for Structural Insulated Panel. SIPs are a sandwich of OSB and expanded polystyrene, rigid foam insulation, or EPS. They are fabricated in a factory and shipped to the site. SIPs have a high R value and speed the construction process. Composite ICFF blocks are a green building product made of a mixture of recycled expanded polystyrene, Portland cement, and a proprietary admixture and water. 100% of the EPS can be recycled. Advanced framing. Advanced framing, also known as optimum value engineering, or OVE, is a system of construction framing techniques designed to optimize material usage and increase energy efficiency. For conventional framing, 2x4 or 2x6 studs are spaced 16 inches on center. Advanced framing uses 2x6 wood framing spaced 24 inches on center, where double top plates are replaced by single top plates, 3 stud corners are replaced by 2 stud corners, and multiple jack studs and cripple studs are eliminated, thus reducing the amount of wood required to construct.
Libby, can I interrupt? I don't think your slides are showing if you have slides yet.
Oh, okay. None of them are, okay, let me try that. Thank you, guys. All right, let's go back to this learning objective. Did you guys see that? Can you see that now?
Yes,
Yeah.
we can see it now. Yes.
Okay, all right. So let me go through the slides. So we talked about fresh killed landfill. Here we've got SIPs. ICFs. Advanced framing. And now we're on to pre-cut framing. Pre-cut framing is a pre-cut framing package that makes framing better, faster, safer, and greener. The advantage of this process is efficiency, speed, accuracy, quality control, no waste, and optimal use of labor. Packages of pre-cut wall framing members are delivered to the job site with all components marked for easy assembly. Prefab, we all know about prefab. Prefab and modular construction offers energy efficiency and sustainable construction. Traditional construction methods require extra materials that lead to increased waste. However, since prefabricated subassemblies are constructed in a factory, extra materials can be recycled in-house. Also, the controlled environment of a factory allows for more accurate construction, tighter joints, and better air filtration, which in turn allows for better wall insulation and increased energy efficiency. Building reuse. One of the best ways to reduce waste is not to build new at all, but renovate built from the existing building stock. Also termed adaptive reuse, reusing existing buildings greatly reduces the amount of materials and waste. 2021 Pritzker Prize winners Anne Lacaton and Jean-Philippe Vassal, who have vowed never to demolish what could be redeemed, instead make sustainable structures from what already exists. Here is an image on the right of one of their projects, the Palais de Tokyo in Paris, originally constructed in 1937 as an art museum and now reimagined as the largest center for contemporary art in Europe. Or on the left, famously, the Tate Modern by Herzog and de Meuron, who converted a London power station into a grand modern museum. Recycled and reclaimed materials. Like building reuse, recycled, salvage, or reclaimed building materials, which are recycled for reuse, originate from buildings that have been deconstructed rather than demolished. Examples of materials that can be reclaimed include bricks, slate roofing, ceramic tiles, fireplaces, doors, window frames, metal fixtures and fittings, stairs, stone, steel sections, and timber. Local resources for salvage materials include Randazzo in Castroville, Jackal Enterprises, and Habitat for Humanity. Also, if demolition is part of your scope, putting it in your specs where the salvaged materials, millwork, or structural components go further reduces impact on landfill and fees. Other strategies to consider include materials with high recycled content, durable materials that will last a long time, materials that can be easily recycled or dismantled, ductless HVAC systems, or buy materials from companies that will take back product at the end of their lifetime, such as Interface carpet. All of this should be outlined in your specs. Circular economy. What is circular economy? This would be a whole lecture unto itself, but briefly, a circular economy follows the same principles as we've touched on earlier, looking beyond the current take, makes, waste, extractive industrial model to a model which allows for material utilization, designing out waste and pollution, and regenerating ecosystems, like the Fresh Kills example. The circular model builds economic, natural, and social capital. Along the same lines is cradle-to-cradle thinking versus cradle-to-grave, where a product has a circular lifespan versus a linear. Cradle-to-cradle thinking is holistic, economic, industrial, and social framework that seeks to create systems that are not only efficient, but also essentially waste-free. And finally, digital design tools. BIM, or Building Information Modeling Technology, is a useful tool that is making the construction industry more environmentally sustainable and economical. BIM combines technology and construction to help contractors and companies visualize the scope of the project through 3D models. The integration of technology and construction can visualize cost and material differences, which can therefore reduce construction material costs and wasted labor hours. It's also great. It also allows for greater collaboration across disciplines, which in turn make for a more efficient process and helps eliminate on-site systems conflicts. In summary, reducing the amount of waste in a project is a critical component of the sustainable vision and begins with the design process. Choosing alternative methods of construction, such as prefabrication, modularization, and off-site construction techniques, in addition of circular materials and systems, are effective ways to design out waste. Thinking about cradle to cradle versus cradle to grave is a key to eliminating waste at the landfill. I'm now going to introduce John Teliha, project manager at Otto Construction, a local construction firm and sponsor of the AIA Monterey Bay. John is going to speak on his perspective and experience with construction waste management at the job site. Contractors are the bridge between the architects and waste facility and it's critical we work with our contractors from the start on ways to make our designs more efficient, plan out waste storage on site, and avoid costly surprises. John, you can take it from here.
Well, thank you, Libby. I appreciate that. And it's an honor to participate on the panel today and speak on this topic. As Libby said, I'm a project manager based here in Monterey, but Otto Construction has been in business since 1947. We're coming up on our 75th anniversary next year. We are originally based in Sacramento, but we've had an office here in the Monterey area for the last 25 years. We focus on a variety of projects, anything from education, healthcare, municipal, parking structures, residential, renovations, kind of a little of everything. And some of our more recognizable projects here in the local Monterey area would be the Major General William H. Gurley VA outpatient clinic, as well as the CSUMB Academic 3 building that was completed a couple years ago there. So you may be familiar with some of those projects that we were a part of in the past here. Okay, so we'll go on to the next slide. Right. So speaking from the contractor's point of view, collaboration is probably the most important element of the project for us. And the sooner that the contractor can get involved with the planning of the project, the more beneficial it is from our point of view. But we find that it's also very beneficial from the overall project's success. First and foremost, from our point of view, really understanding the goals of the ownership or the owner themselves in regards to what are they looking for in relations to sustainability, if that is a priority. Is the project focused primarily on budget or costs? Are they wanting to publicize that they are sustainable, or are they looking to actually try to achieve the LEED certification? So really having a good understanding up front of what are the goals from the ownership group is very beneficial for us, so that we have a clear direction as we move forward. And it also helps the rest of the team have that understanding as the objective as we move forward in the project. And then working directly with the architect, ensuring that whatever specifications in regards to the details for the waste management are included in the specifications for the project. That way it's documented. It has a reference that not only the contractor, but anyone can go back and refer to. And it does give us kind of a blueprint on a plan of what we need to do as we move forward in these projects. After the collaboration initially and understanding the goals,
John, you there? You froze for a minute.
Did we lose John? Can you guys hear me?
I can hear you, David. It sounds like we lost you, John. Maybe he's having a... Oh, he might be starting back on. We'll see if he gets back on, but we'll just have you guys read the slide.
You're muted, John.
Thanks, David. I'm sorry I lost you there for a second. And then also access to the site. Again, those are things that we look at upfront early in the process to ensure that we have adequate access, whether that is to bring in materials, to remove waste, recyclables, those types of elements of the project. So it's basically your site logistic plan and ensuring that you can accommodate what is being proposed for the project. Okay. Next slide, please. Up front too, you want to identify your local landfill and recycling, waste, hazmat removal operators. Really understand the policies and procedures that each one of them require, as well as get a good idea of what fees may be associated with each one of those entities. You want to identify hazardous materials that could possibly be at the site. Again, upfront, knowing what you're dealing with helps you to plan and execute properly. Understanding the local policies and procedures for the hazmat removal and the fees associated with that as well. That would also include your soil conditions. I know sometimes we focus more or less on building materials, but as the contractor, we're also sometimes challenged with the conditions of the soil. There could be naturally occurring asbestos. There could be pesticides, other types of contaminants in the soils that we'll have to take into account as we put our plan together. And lastly, you may want to identify your local air quality management agency and understand their requirements, their restrictions, especially when you're moving hazardous waste or hazardous soil conditions. And then next, you'd want to work with your team, the design team, everyone involved on developing the project-specific waste management plan. And once the plan is in place and adopted, the next step would be to implement it. So that it's very important that you educate, at least from the contractor's point of view, our workforce, our subcontractors. It ensures that everyone seems to be on the same page and understands the priorities in regards to the waste management plan. Designating waste, recycling, and reuse material areas, if you have that opportunity at the site, is very beneficial. And again, it goes back to ensuring that the team that is out in the field actually doing work understands the necessity and the importance of the proper disposal and use of these certain areas, as well as ensuring that we properly protect and cover those designated areas. Again, if not, then it could impact other things such as your stormwater pollution prevention plan. If you are to have materials sitting out unprotected, it could impact and lead to more challenges and possibly even more fees or fines. So important to ensure that everybody's up to speed and involved and understands the waste management plan. Next slide, please. Touching on some of the items, practices that Libby had mentioned up front, that we as contractors look at our recycling, again, sorting of materials, materials that cannot be reused at the site, so properly identifying those. Repurposing or donating materials. This becomes more and more popular today. And things such as appliances, doors, fixtures, they can not only help with the job site, but it can also benefit others that are interested in those materials. As well, it could be a potential tax benefit to the owner as a donation. I'm working on a project here in Seaside on a apartment renovation. It's 192 apartment units. And we worked with Habitat for Humanity on the donation of a large number of appliances and so forth. So again, it goes back to it doesn't have to be disposed of. It can actually end up being a benefit to others in our community. Deconstruction. It is a practice that is beneficial, but it's beneficial if you are not under time constraints as a project, and it's less efficient just because of the time it takes, and it could be even more costly because of the additional staffing that would be required to deconstruct. But it is, it seems to be what they find is a less impact to the environment, unlike the next item, which would be the demolition. Demolition obviously would be quicker. It is more efficient, so you're not going to need as many staff members to do that work. But findings are that dependent on the materials, they could be more impactful to the environment. Reuse of materials such as untreated wood, drywall, asphalt, gravel, concrete. Many of these items, again, up front in the planning with the design team and so forth, understanding what is planned to go back or being built, there may be the opportunity to reuse some of the existing elements to help offset some of the need for materials as we move forward in the construction phase. You know, we see a lot of the reuse of ground asphalt or gravel, concrete, utilizing to be for base under flat work, that type of thing, repurposing that. So again, just getting up front, identifying what is existing and what is planned to go in place, and see if there is any opportunity to reuse any of those materials. Design standards, as Libby touched on in one of her slides, the standardization of dimensions for construction, looking at more prefab modular type of construction. If there's more construction within a plant or a factory versus out on the field, you are less likely to have as much waste. That's what we're finding. Next slide, please. And from a contractor's point of view, some of the challenges for construction waste, and again, I've touched on some of these, but again, the size of the project site, that can be a huge challenge for us as we get out into the site, and actually dependent on the detailed level of the waste management plan. There could be a lot more coordination needed with the appropriate off-haul operators in regards to the frequency of loads, the size of loads, those types of things, and the coordination of access, as well as the construction happening at the same time. The phasing of work, phasing of work is it's critical, obviously, for the schedule, but sometimes it does put some limitations dependent on the method that we're using to whether it's demoing a building or reusing certain products. Just factoring in and looking at how that work can be phased as we remove one element, and how do we incorporate it into the new portion of the project. Again, another challenge that I touched on was just the education of the workforce or subcontractors. Just reinforcing the importance of the waste management plan, the need for it, and ensuring that it is being adhered to properly. And then lastly, the inefficient or unreliability of the waste recycling or hazmat removal operators. We rely on them a lot to meet their schedules, meet their time frames. Again, if I have too much waste at the site, it can impact other staging areas. So it's just ensuring that we have a good working relationship with those partners, and to ensure that, again, they follow the waste management plan. Next slide, please. A success of construction waste management would be one of the projects that I touched on earlier, the CSUMB Academic 3 building. It was completed in October of 2019, and it was awarded LEED Platinum certification. Fortunately for us, I did not personally work on the project, but fortunately for us, and it's my understanding that we had a nice site to work with. We had plenty of space to set aside designated areas for recycling and waste and so forth. Working close with the Director of Sustainability from CSUMB, understanding the goals of the university, as well as the architect, WRNS architects, and looking at the materials that were going to be used. So we were fortunate enough to, again, be a part very upfront in the process, and had a good understanding of the project, the goals, and as a result, it was granted the LEED Platinum certification. So very, very proud of that accomplishment, and very, very happy that we were a part of that team and that project.
Thank you, John. That was great. If people have questions for John, we're going to hold that for the end of the presentation. So I'd now like to introduce David Ramirez, Senior Engineer at the Monterey Regional Waste Management District. With a background in civil engineering, David is the main project manager of the facility, involved in the operations and implementation of local, state, and federal regulations. We'll have David talk a little bit more about his responsibilities there at the facility. But before I turn it over to David, we have another poll, survey number 2. Charmaine, can you post that for everyone, please?
Yes, and Libby, I made you co-host, so do you want to try to see if you can do that with that designation?
Yeah, I can. I'm gonna try, let's see, try that. Just trying to get out. I don't know if I can get it on my screen. Oops. Oh. All right, I think I just messed it up. I can't get out unless I stop share. Let me try that.
I'll do it. That's fine. No, it's okay. I just was checking to see like if something we can do number 2.
Hopefully no one saw the answers.
So it's for
Okay.
not seeing number 2 come up when I click polls.
Okay.
All right.
Let's
There's 1. Okay, got it.
poll number 2.
Here it comes.
There we go. What is the greatest amount of material recycled at the Monterey, the regional, I think I put the acronym wrong. Okay, we're seeing, looks like metal's in the lead. Metal is tied with concrete. All right, let's see, we've got about 7 people answering. All right, you can end the poll. And the answer is fines. David, maybe you can talk a little bit more about that, but please introduce yourself, and then I'll stop my screen share, and then I have one last poll for the end there.
Sure, yeah, and it's usually pretty surprising to everybody that fines is the #1 recycled material that we get out of our C&D construction, demolition, debris sort line. So that is just basically dirt and small particles that get shaken out of the material. They fall through out of the mixed waste, and they fall down through the machinery that sorts it. We take that dirt and we actually use it to cover the landfill. So instead of harvesting virgin sand material or buying a product that we can spray onto the landfill each day, we use that for daily cover. So it's a very useful material in our world of waste management. And I have my screen up now, so somebody tell me if they're not seeing that.
Looks good.
All right, so like Libby said, I am from the Monterey Regional Waste Management District, which I understand is a mouthful, Libby, so don't feel bad about getting it wrong. And our motto is turning waste into resources. And if I can take a philosophical moment here, we think of waste, we think of it as a noun, right? We think of it as a thing, something that's outside of ourselves, but really waste, it's a verb. When we don't use a material again, we send it to a landfill, we're wasting it. So if we change our mindset about waste and like construction waste, these are valuable materials that we could be using in other places. So keep that in mind as we go through this presentation. The district was established in 1951, and the landfill's been in operation since 1965. A number of years ago, probably in the early 90s, we started to discuss internally at the district about this notion of circular economy and waste hierarchy, and ways that we could reuse materials instead of throwing them in the landfill. And as Libby said earlier, there's the model of take, make, and waste is a linear economy, which we're all accustomed to. But what we really want to do at the district is be involved in the circular economy, where we are part of the reuse and recycling. So you see that on the left. On the right-hand side is the waste hierarchy. And you can see you want to be as high on this pyramid as you can. So first off, you want to perform waste prevention. So if you can reuse a building or repurpose a building, then that's something that is obviously very useful. Then preparation for reuse, demolishing or deconstructing the facility in a way that you can reuse the materials, recycling and composting, other recovery, and then finally at the bottom, disposal. We at the Monterey Regional Waste Management District have a number of facilities on our site. We have a reuse store, which operates much like a Goodwill does. So materials that are useful that we find at the landfill or at our material recovery facility are pulled out and sold at our reuse store. We also accept donations at the Last Chance Mercantile. We also have a Class 3 landfill where we dispose of materials. We have a single stream, I'll use the acronym MRF, but for material recovery facilities, and I'll pronounce it MRF. So if you hear me say MRF or see it, just understand that means material recovery facility. So single stream recyclables are your blue bin, what you put in your recycling cans, bottles, paper, cardboard. Those all come to our facility. We sort them into their individual commodities, and we sell them to recycling companies. And then C&D, we also have a C&D MRF. C&D we shorten as construction and demolition debris. So we do sort through that material as well. We have a 5 megawatt power plant on site where we take landfill gas and turn it into energy, and we're considered a renewable energy source. We also have a compost facility at our site. So we take the community's green waste and we compost it, turn it into a ag product that gets spread on local fields in our agricultural areas. So this slide is probably, the content on the right-hand side is probably the biggest takeaway I'd like everyone to have from my presentation. It's please identify and contact your planned disposal facility. They are remarkably different in what they accept. There are some hazardous waste landfills. There are some non-hazardous waste landfills. There are some recycling facilities that will take materials, but they have to be prepared in a certain way. So please, as you're doing your designs, try to think through these things, because there's nothing worse than having a contracted hauler drive up with a load of asbestos, and then they can't dump it, and then they find out there's all these regulations, and it's just a huge mess. If you find out near the end of your project, when you're doing your demolition, that your local landfill can't take it. And this is as a client of architects and contractors myself, this is one of those things that owners may not see, but they'll notice. Projects will run smoother if they go with you. If you start thinking about these little details, for some reason, the projects will go smoother for them. They won't have these big unknowns come up at the end of the project. So please contact or think about the disposal facilities in your area as you're talking about demolition or waste disposal. So I think I covered all that's in there. Yeah, that last bullet is important. Conduct material surveys early to alert the client of potential costs to avoid change orders. If there's asbestos in the building, you're gonna want to identify that early. Lead paint, and John mentioned this earlier. Soil contamination. There's, you write a certain amount of off haul for your soil when you're doing an underground parking lot structure or something, but where is that soil going to go? If you help identify that for the client, they're going to be much better off when they're going out for bids, and the contractor is going to be a lot happier that they're not finding out as they're trying to dispose of the soil that there's something, there's some contamination, like a gasoline spill or an underwater aquifer that brought gasoline through there. That's something you want to avoid. I'm going to go through these slides and kind of as the disposal hierarchy would prefer them. So on our site, we do have the reuse store, as I mentioned, which operates like a thrift shop. This is pretty much the inside of it with very low stock in this picture. It's much more stocked these days as people are cleaning out their homes as they're staying home. We also have a rear yard that's full of dimensional lumber, furniture, a lot of other materials that folks bring us by donation, and we resell it to very, very pleased customers. And as you get onto the construction site, this is the ideal, right? But not always possible scenario where you have enough space that you can put out these bins where you can collect your steel, wood, concrete, and your employees or your contractors' employees are educated well enough that they know where their materials are supposed to go. So this is an example of what can happen on the job site, and something to consider as you're putting together your construction waste management plan. But then that material comes to our facility, and we operate a C&D MRF. In the state of California, 65% of all new construction materials are supposed to be diverted. Waste materials are supposed to be diverted. We operate the C&D MRF at a rate of 75% diversion. So any mixed loads that come into our facility are given a 75% diversion rate, so that they can show the county that they've achieved the required 65% diversion. But that comes at a cost of $65 per ton. If you do source separate your materials as shown in the previous picture, you have much lower rates for the disposal of the material. So reuse donations are free. Metal we accept for free. Cardboard we accept for free. Drywall has a reduced rate of $30 per ton. Green waste has a reduced rate of $42 per ton. Dimensional lumber, $42 per ton. Carpet comes in for free. Stumps, $40 per ton. Concrete, $1 per ton. That's a big one, right? You have a very heavy material that if you have it mixed into your waste, it's going in at $65 per ton. But if you can source separate that, you get it at $1 per ton. So concrete and asphalt are the same. Same thing with clean soil. There's an incentive to keep all your trash and everything out of the soil. You can get that in for $1 per ton. We'll talk more about soil and the differences between clean and not clean soil in the future in a couple minutes. Appliances, $5 each. Mattresses free if less than 5 units. If above 5 units, it's $5 each. So there are some cost savings to consider. Whether or not they outweigh the labor costs in setting up this, that's another story. This is an actual picture from one of our cameras at the MRF. This is where the contractors will come in, back up their trucks, and dispose of their materials. And the next view is going to be just to the right of this, or just to the left of this. I'm going to go back real quick. If you can see off in the distance, there's a big kind of mound of material back there. You guys see that behind the loader and behind that blue container? That's all wood. That's dimensional lumber that we've pulled off from the sort line. That will get chipped and turned into wood chips. But this is the material actually getting loaded into the hopper of the MRF. So we have an excavator who chomps at the material and tenderizes it and gets it down to a smaller size, and then it gets loaded into the hopper on the left and it goes up to be sorted. And then this is the top of that line where the material's coming through, and we're pulling off metal, we're pulling off wood, we're pulling off concrete. If you can see upstream of this belt, there's kind of this grate looking thing, kind of grates. That is the shaker screen. That's where the small there's these rolling discs, and the small particles will fall in through those discs, in the gaps in those discs, and then that'll go and be the fines that we talked about earlier. But it's manual removal. We're not getting everything. Our folks are not 100% accurate and 100% recovery. So if it comes in mixed, we're grabbing what we can as that belt moves by, and we're taking it. They're stopping the belt if they get a good piece of concrete that they can pull off. But the majority of the material that you see here on the bottom, that's all going to the landfill because they just can't sort through that stuff quickly enough. So when we do pull off a large block of concrete, it goes to our concrete recycling area, and it's basically a concrete crusher. We load that material onto the crusher, it crushes it, and we're able to create a Class 2 base rock that Don Chapin sells as a Class 2 aggregate base, recycled road base. So one thing to consider is speccing out recycled materials, because if they're not specced out in your design, we need a market to be able to sell these materials into, so that to make it beneficial for everybody to keep doing this. And incentivize people to keep recycling the material. So consider that in your designs, please. The use of recycled materials. And then here's a similar thing happening with the wood. When you think about, is this the best use for the lumber? Getting chipped up and put into used as ground cover wood chips. There's probably better uses for the lumber than this, but this is the most efficient thing we can do with the lumber as it comes in. So this is where reuse really matters. As an architect, you want to think about how can we reuse this structure, because chipping something up into wood chips is beneficial, but not as beneficial as that dimensional lumber, which you pay a premium to get it rebuilt or remade. And then the last home of things is the landfill. You did mention Clean Harbors landfill being turned into a park. However, hold on, give me a phone call. That park still has 50 to 70 years of management. That waste that is produced today will create greenhouse gases, methane, for 50 to 70 years after it's been put into a landfill. So what we really want to avoid putting things into the landfill just because of the long-term environmental impacts and environmental management that it's going to require to monitor this this decaying mass. So it's why we want to try to reuse as much as we can. At our landfill, which is known as the Monterey Peninsula landfill, it's a class 3 landfill. It's the lowest grade landfill that you can have. So we can only accept municipal solid waste. We cannot accept hazardous waste. We cannot accept friable asbestos, lead, or anything flammable, reactive, or corrosive. So this is a landfill that's the lowest tier in our community of disposal. So we're very selective on what types of material we can accept. The next closest landfill that's a class 2 is in Livermore. And if you end up having to take any of your materials there, it's going to be a huge cost to your project. I mentioned earlier clean soil being $1 per ton. And this is where I want to reiterate it, because a clean soil means non-contaminated and without garbage or debris. If we do have soil that is contaminated, say there was a nearby gas station that leaked fuel into the soil and it has some baseline level of contamination in it, then the petroleum contaminated soil is $20 per ton. So you have 20 times more cost in disposal for a soil, which is a pretty heavy material. That's a huge cost to your client if that's not identified early. And this is contaminated soil that's within our acceptance thresholds. Like I said, we're a class 3 landfill. We cannot accept hazardous waste. So if you have a soil that is more contaminated than our thresholds, then we can't even accept it here locally. Not here at the landfill north of Marina or at Johnson Canyon landfill, which is down near Soledad. Neither one of those landfills can take it. You've got to take it to another facility, which is probably Livermore. So those are huge costs to consider. And I hate being the one to tell that. Yeah.
I'm kind of jumping in here real quick, but who sets those thresholds?
So those thresholds are set by our individual landfill permit, and the designation as a class 3 landfill by an organization, a regulator called Cal Recycle, which is the state. They are our oversight one of our many oversight agencies, and they have these set limits that are set for class 3 landfills. And every landfill has a different requirements for how they want you to submit to them of the type of soil. You know, they may want more tests than another landfill may want. So you would do well to call a couple of options and find out what their requirements are, and inform your client that, you know, this is something that they should consider if they have a significant off-haul. Then lastly, treated wood waste is something that's been talked about recently. On January 1st, 2021, treated wood waste, which can be identified as wood that is for outdoor purposes or in contact with the ground. There's preservatives that are injected into the wood to make it last longer. It's characterized by these little staple marks that you see in the pictures here. And there's also a coloration to it, usually green or blues or some kind of tint to it that doesn't look natural. That wood is actually hazardous waste once you're done using it. So, as I mentioned before, a class 3 landfill cannot accept hazardous waste. Well, there was a alternative management standards which allowed us to at our facility to accept that treated wood for a number of years, for probably 10 years or so. And on January 1st, 2021, the state lifted that alternative management standard, and all of a sudden it became illegal to dump treated wood in our landfill. However, they did allow us to apply for a variance to accept it. And as of now, we are able to accept treated wood, but we are required to obtain quite a bit of contact information and customer identification information so that we can report that information to the Department of Toxic Substances, the DTSC, and they can follow up with the customer and let them know whether or not they are required to get a variance to transport it. Because as a hazardous waste, you can only transport 50 pounds of a hazardous waste unless you have the right permits or a variance to transport that material. So for instance, if you as a homeowner are demolishing your fence and you've got one load of treated wood waste and you come into our site, we will allow you to dump. We will take your name, your number, your driver's license number, your license plate number, and then you'll be able to dispose of it. And if you never show up again that year, you're going to be fine. You're probably not going to be contacted. But if you're a fencing contractor and you're demolishing fences every day and rebuilding them, and you are coming in every day of the week to dispose of those treated wood waste products, then we're required to report it to the state, and then they're going to get in contact with those folks and let them know that they need a variance to haul that material. So that's something to be aware of. And that's over to you, Libby.
Okay, great. Thank you, David. That was really informative, and I've got a bunch of questions here that I'd like to ask. But I have one last poll, and it's a test. So I'm gonna go to the next question, and just to see if I'm gonna test everyone's memory. What is the California maximum diversion? All right, you guys were quick and got that right. Okay, all right. I'm glad to see you're paying attention. Oh, okay. We got a 50%. All right, I'm gonna end the poll. and it's 65 is the answer. I'm going to just share my screen for the ending here and pull that up. Okay, I'm going to share the results. So, yeah, half of you guessed 65%, so that's the right answer. And that can also go right in your specs, but that is what the landfill is requiring. Okay, I'm going to just share my screen for the last few minutes. We're right on time. It's 1 o'clock, and I'm going to open this up to questions and first, let me just pull up my slide here. Actually, let me keep this on for now. We'll just have our faces showing, and I'd like to open it up right now. So I guess please, everyone, feel free to either post a question. I'm going to have Justin moderate those questions, and then otherwise raise your hand. Let's see, there was one question in the chat, David, about the Last Chance Mercantile. Is it open now?
Our board of directors recently approved the Veterans Transition Center to take over the operation of that. And the planned opening date is sometime in July.
Okay. So can we bring things to them yet, or
Not yet.
hold up?
No, not yet.
Okay. All right.
All right, Libby, do you want me to take over on
Go
the
for
rest of
it.
these questions that we're getting in the Q&A here?
Go for it.
Okay, I believe this one is directed at you, Libby, and your introductory slides. It's from Matt Kremer. Do you have case studies on the alternate construction methods discussed? What is the cost difference between deconstruction and demolition? What are the requirements for determining if deconstructed material is appropriate for reuse in construction? I'm not that could be for anyone, actually, not just necessarily.
Yeah, I don't know the answer to that.
Yeah.
Maybe John?
Yeah, I don't have a specific answer for that either. I think it can vary project by project, but I'm sure that there's case studies out there that can be referenced in regards to the comparison of the methods.
Yeah, what about that last question there? What are the requirements for determining if deconstructed material is appropriate for reuse in construction? I mean, there's so many variables there that could affect that. I mean, there's, lead paint content and things like that. There's the structural integrity of the material, the visual quality of the material. I mean, can you guys think of anything else that might inform a response to determining whether deconstructed material would be appropriate for reuse in construction?
Again, it's project specific, but getting involved early in assessing the materials up front of what is being proposed to be removed would be a benefit to that project.
Okay. Matthew Kyler had a question, and he was asking, what are the lead limits specified which can be sent to a class 3?
Yeah, that's 800 milligrams per kilogram for a TTLC, and the STLC value of 0.5 milligrams per liter. That's for our facility.
Great. And this is sort of an interesting question from Matt Kremer as well. what is the life expectancy of a landfill? I've often wondered that myself. Like, how long can these things continue to operate, sort of disking that stuff into the ground before you sort of hit your capacity of what you can put in the fill there?
Yeah, all landfills have a permitted maximum elevation that they can fill to. So, and it depends, and the life expectancy is a big question, because what are we going to be doing in 25 years? How are we going to be, how is waste, how are waste activities going to change in that time? So the more accurate numbers are the ones that are smaller. So there's some landfills that have less than 5 years. Those are probably more accurate. The landfill that I'm involved with the Waste Management District has a life expectancy of 100 years. But you know, that with that time frame, there's so much that can change, and the life expectancy hopefully increases, and hopefully we never fill it up. But we're permitted to that, you know, that certain volume.
So that's really interesting, David. So literally there's like a physical like datum point that in the landscape that you can fill up to, and then all of a sudden you're capped. Is it just like, do you have to fill that up like across an average height of the landfill, or is it literally just like once you hit a certain height at any part in the landfill, you guys are done? It's
a footprint and a height, and then the standard slopes that we have to achieve. So it's really a well-defined volume. So you know, the landfill has its footprint on the ground, and then the prism that goes up to that elevation and you calculate the volume. So it's a pretty set number.
And so you guys have estimated 100 years. Is that 100 years from when you built the landfill, or is that like 100 years from now?
From now, but like I said, things can change. It could increase. We could slow down the rate that we're filling it, and then it could be 150 years.
Yeah.
There's a lot of things that can change it. For instance, SB 1383, which is a upcoming, or it's legislation that's already passed, is banning any organic material from going into the landfill. And I use the term organic in scientific terms. It's anything that's been alive recently. So you know, paper or wood or any, you know, biosolids, those kind of things cannot go into the landfill anymore, because when they go into a landfill, they decompose anaerobically and produce methane. And we all know methane is a greenhouse gas that's way worse than CO2. So we want to get it out of the landfill and do something else with it. What that something else is probably composting or some other kind of beneficial reuse. And that's going to change the life of the landfill. 40 to 50% of all the waste that goes into the landfill is organic matter.
Yeah. Well, I'm not seeing any more questions in either the chat or the Q&A. So unless the panelists have any questions themselves, or if any participants want to throw in a last question, I think it's time to say thank you to both David and John for participating.
I've got questions.
Oh, Libby's got some questions.
Don't close it out too fast.
Okay.
So no, thank you guys. You know, this is really this has been a really good discussion. I hope it's been beneficial to the participants. I had a couple questions that came up. David, can we circle back to pressure treated wood? I know I've spoken with several contractors who are happy that now they're able to dispose that there. Why can you just explain again why the recent change in accepting it? And then, you know, what do you do with a pressure treated wood, and can it be resold? Because, you know, there is a use for it, and it would be great if contractors could go back and maybe reclaim some of that for projects. I don't know.
Yeah, my experience is on the waste side, not necessarily on the regulations of treated wood being reused. I will say that if your materials are not, it's not a hazardous waste if it's being put to use. So if it's in your backyard, it's not it's not classified as hazardous waste. If you're transporting it from one job to another, from Home Depot to a job site, it's not hazardous waste. So you and I, Libby, can go to the store, buy it at Home Depot, fill our trucks up with it, drive it to a site and use it. And that's not a hazardous waste. Once we've deemed it a waste from a job site and put it in our truck, the cuttings from that job, we put that and fill it in our truck and start driving it to the landfill, then it's a waste, then it's hazardous waste. So, the classification changes if you're using it or if you're not using it. So I'm not sure about the ability to reuse treated wood. John may know more about that, but I would say it's being reused, and so therefore it can be put to beneficial use. It's not a waste. So I don't know if that answers your question, because I don't really know about that. But once it starts headed towards my direction, it's hazardous waste, and you better have your variance. So you asked also about why the change, and this was not a change that the landfill did. This was decided up at the state legislators and the governor. There was a bill that came across the governor's desk that would have extended the ability for a Class 3 landfill to dispose of treated wood, but the governor vetoed it for whatever reasons he had. He vetoed that bill that would have extended that ability. So it really threw the industry into a tailspin, because nobody had anywhere to take it. They had to take it to the one landfill in Buttonwillow, California. And there's just there's nobody that's going to do that economically. And we were not allowed to receive it. We were allowed to remove it from being disposed of in a landfill. And we had our own waste bin that we sent to Buttonwillow, but we couldn't, I couldn't tell John, yeah, just bring it in and we'll send it to Buttonwillow for you. That would have been illegal. We had to exclude it from our acceptance list. However, the State Department of Toxic Substance Control realized there was a huge need for people to dispose of this treated wood, and that it was going to end up on the side of the road if it hadn't already. People were going to just dump it on, illegally. And so they created a pathway for a variance, and a variance is a alternative way of disposing of this material. And so they put all these requirements on Class 3 landfills to collect information from contractors of who they're getting the waste from, how are they transporting it, and where is it getting disposed, and to create that paper trail so that DTSC could follow up with folks who are not following the correct protocols. So it really wasn't something we decided. It was handed down to us to do, and it's all landfills in California that were in this same scenario.
Okay. And I had another question about fire cleanup. We had 3 fires in our region last year. Things like ash, where can debris from the fires be taken to your facility?
Yeah, when something burns, it concentrates all of the chemicals or constituents that are in there, because it really concentrates those metals. It concentrates any contaminants that you have, asbestos, other materials. So the county and state health departments and CalRecycle went through each one of these burned properties and had to remove all the hazardous waste that they could readily see. But then that ash had to get tested to make sure that it went to the right facility that could accept it. So we are at our facility, we're able to take fire debris, but there are a number of regulatory requirements that the homeowner needs to go through to show that the site has been cleared and cleaned, and that the material, the ash that's going to come to our site is not hazardous waste. And we've received only a handful of projects where the homeowners have been able to do that cleanup themselves. Most homeowners are opting into the state of California's cleanup program. And that program is when the state gets to you, when the state has the resources to get to your property, they will come and clean it up, and they decide who's going first in whatever way they do. But other homeowners have decided they wanted to opt out of the state program. And so they've got to do all this environmental testing themselves and hire firms to do that testing. So if you do have a client who's trying to remove fire debris and fire ash on their own, make sure they contact the Monterey County Health Department, because they have to follow a certain set protocol to get their site cleaned up. They can't just drive a truck up there and load it up and try to drive it to our facility, because we will turn them around and we will not let them dump.
Mm-hmm. Okay.
Unless their paperwork is all in order, of course.
Yeah. I've got two questions for John. Kind of going back to construction techniques. I touched on lean construction, which eliminates or minimizes waste at every opportunity. How is that? Have you done lean construction, and who is it the architect or the contractor that brings that concept to the project? How does that start?
Sure. Yes, that is a practice that auto construction does work with. It's been around for quite a while, probably 10, 15 years, the concept. And we're finding it more and more popular today. You touched on it. It is a way to be more efficient and to save waste. And what we found is that we typically bring that to the design team. So it comes from the contractor side. One thing that we focus a lot on is there's a principle or an element of the lean construction is the pull planning. And that is basically getting all of the design team, your subcontractors, involved in planning out or mapping out the schedule of work that will be that will take place for the project. This can be what we call in the old way would be a timeline on a wall, and everybody would have a set of sticky notes, and they'd kind of go up there and paste them up on the wall. We are now working with a visual collaboration software called Miro, and that's where we can actually take that concept and actually do it virtually. So it still provides you on a screen a timeline, and the contractors as well as the design team can log in, and you'll have your virtual post-it notes, if you will. And we have the ability to move those post-it notes around, if you will, and really have some good conversations about the methods of the construction, the processes, the sequencing of the work, and so forth. And so we're finding that has been very beneficial in these projects. And again, that is one principle or element of the lean construction. I know that there's more, but that is one that we commonly use in our projects.
Okay, great. And in this talk, we've mentioned a lot about materials, but we haven't talk about packaging, and this is one of my biggest pet peeves. John, what are you seeing at the job site with regards to packaging? Is it recyclable or not? I know there's a lot of soft plastic that is difficult to recycle. What is being done with that? And is there any option for companies to take back their packaging?
Yeah, that's a great question. And I meant to come back to that. I touched on it a little bit earlier in the presentation in regards to bulk ordering. If that's something that you can coordinate with your vendors, it is beneficial. One thing that kind of led us to bulk ordering was more or less just the COVID-19 and ensuring that we could get materials as more or less the economy and our suppliers were closing down due to the pandemic. So we were ordering in bulk, trying to stay ahead of the supply chains and ensuring that we could keep working through the pandemic. We found with that some efficiencies, also some cost savings by ordering in bulk. And the waste was more or less we could calculate or expect the delivery and the waste, unlike if you're ordering it at different intervals. We could schedule larger removals at one time versus having several over a period of time. So we also did coordinate, as you mentioned, with them on just eliminating some of the packaging or reducing some of the packaging or taking the packaging with them. We found that, for example, the renovation of the apartments here, we worked hand in hand with a vendor, and they would deliver the appliances and they would unpackage them for us and take the packaging away. So again, that was a benefit to the project, and then they were able to take that packaging and either reuse, repurpose, or recycle it. So yeah, the more, again, you can kind of get out front of it and really work with your vendors and subs in regards to how you can reduce the waste and possibly save some money, the better off you're going to be.
Mm-hmm. And I think, having these early conversations with the contractor, we talked a lot about collaboration between the architect and contractor. And I think that in addition to putting this in our specs, just to communicate to you saying, look, to help everyone out, we want it, can you ask your vendors to take the packaging back? Or, because again, the industry is not going to change until we start putting pressure on people to reduce the packaging. Obviously we need to protect the, fragile materials, but so I thank you for answering that question.
Sure.
I have another question kind of posed to everyone here, and if there's any structural engineers on board. I am interested in the advanced framing, and, is that something that as an architect we need to just specify, off the start, like we want you to do everything in 2x6s, or will the engineer or contractor bring that to, the engineer, will they bring it to the table as an option? I'm singling out someone here.
So, I've had 2x at 24 inches on my specs for 3 years now, and I've yet to see any of my projects built with it. So I think that I need to do more in my standard details to really lay it out. But I think that some of the ideas from advanced framing that can be readily used are asking your engineer to size headers correctly for their demands instead of just using a standard header table. And when you see a standard header table on a sheet, ask them why, because that's going to be one of your biggest savings, is actually getting somebody to use a header that is appropriate for the job instead of just slapping 4x12s in on every window that in its existence. So that's one of the main points. And then just having that conversation with the contractor early to set an expectation.
Okay, that's great. Thank you.
Yeah, and I'll
Matthew.
tell you, and from our perspectives, depending again, it just job specific, but if we're doing some type of educational facility that is has DSA requirements, that we are bound by the guidelines and so forth. So we don't really have the flexibility to offer some of those options. Again, dependent on the project itself. So more the private side is more where we see where there could be some flexibility or some options in the framing. But when it's dealing with whether it's healthcare, education, that type of project, we're more bound to the regulations that we have to follow.
Okay. Well, we're almost at the end of our time here, and this has been a really great discussion. I'm just going to kind of share my screen for one last slide here. And these are our questions and answers. So in summary, although our local landfill is doing their best not to reach capacity, and many landfills are set to close due to overfilling, recycling construction waste benefits the environment by cutting down the extraction of virgin resources and returns the usable materials to the construction industry, limiting the demand for newer products. And as we've seen, reusing materials that would be normally abandoned, lessen the burden on landfills and achieve long-term environmental healing. Plainly stated, if we plan out our projects with waste reduction in mind, we can eliminate excessive waste. And really, what is the real reason we're doing this? It's not just to conserve resources, but to make this a cleaner earth for our future generations. And through a concerted effort and collaboration, as we've mentioned here, I believe we can get there, or we can get there. I'd like to thank John and David for participating in this webinar with support from our COAT committee and Tremaine Jones, our executive director. Thank you all for being here. Check out the links I sent in the chat, and the recording will be posted in about a week or so. Thanks again, everyone.
Thank you.